Hello. Hi, everybody. Welcome to the Just in Time Cafe's webinar. I'm Elizabeth Swan, co-founder of the Just in Time Cafe, and I'm going to be your moderator today. No Tracy, just me. Today's webinar is titled How to Pick the Right Lean Six Sigma Map and Build It. And our guest host today is Jim Athon of the Athon Group. Let me tell you a little bit about Jim. He's been a continuous improvement leader and Lean Six Sigma master black belt for nearly 25 years. He's so young. He's had amazing success in driving Lean Six Sigma methodology, principles, best practices, efficiencies, and increased revenues. Everybody loves that. Jim's got a habit of passionately disrupting tradition by training and mentoring leaders to collaborate with each other. He relies on conviction and data, strategy, and commitment to drive cultural and tactical success. Jim's trained over thousands of black belts, green belts, and worked on hundreds of projects. I've had the honor of working together with Jim over the years, so I appreciate his ability to take complex topics and make them relatable and interesting. I will say that a little known facts about Jim are as impressive as his continuous improvement background. Jim taught me all about things like trebuchets. I get posts from Jim looking at astronomy, looking at the world, and he's also taught me a lot about bad jokes. So I'm just going to ask Jim a question. Why don't pirates play cards, Jim?
Swanee, they're always standing on the deck.
I did not lie about Jim. Welcome, Jim. It's such an honor to have you. It's great to see you. This is a good opportunity in our remote world, a way to connect. Just a few housekeeping notes before we begin the webinar. You can ask questions anytime by posting them into the chat area. I'll keep an eye on Q&A if you've got other questions for Jim, but we like it in the chat, and we love it if you post to both panelists and all attendees, or if you have comments or you want to talk about Jim's office, which is so impressive, then just put those in the chat so everybody can see. Because it's a great conversation that we usually have on these webinars. We appreciate that. Let's see, we welcome your participation. Jim will have some, at least one poll. He might have some questions for you throughout. Videos of our webinars and interactive sessions are all going to be made available. They're on our website. That's the JIT Cafe, jitcafe.com, JITCAFE.com. And we will send everyone who registered for this webinar, like we always do, a link to the recording and any special gifts that Jim has in store for you. We'll include those too. So keep an eye out for that. And before we roll, we just want to find out where some folks are from. So I see you guys have been posting into the chat area. So Jim, I'm just going to tell you where people are from. We got Shane from Lincoln, Nebraska. We've got Tony from exotic Iowa, not just average Iowa. We got Dave from Greenville, Tennessee. We've got Steve from Ottawa. And we've got Manoj from the UK. All right, so we are international with Canada and the UK. We've got Caressa from San Diego. We have a great crew today. This is a nice lineup, and I am going to hand it over to you, Jim.
Brilliant. Thank you, Swanee. Known Swanee since 2001, I guess. We worked together as a client. So we have known each other a great long time, had a lot of success together, a lot of good times. Actually, telling Elizabeth real quick, when we were working together, she got to tell me about some of her work with improv back in ancient times. And it reminded me of efforts I had done in both high school and college in theater, and completely start getting married, have kids, and all that goes by the wayside. And she encouraged me to get back into theater. So I got back involved in community theater, did all sorts of plays and activities and that sort of thing. And a great fun. Makes you really appreciate people who can actually act or who are actually funny, like Swanee. Yeah, give it a shot, but you do what you can. Nevertheless, we got a lot of ground to cover today, and I'm going to periodically check in with Elizabeth, and she's going to let me know if there are specific questions. So she'll be monitoring the chat, and that's any questions that come up, and we'll go from there. So we're kind of switching formats a little bit, going to my slide format. Talk about process mapping, and when I go through regular black belt training, green belt training, even open enrollment, just yellow belt training or white belt, we talk about process mapping, and we'll go through that as a foundation as team-based breakthrough process improvement, brainstorming. There's an interesting quote here by Henry Ford. I'm a big fan of history too, so I've done a lot of study about some of the historical origins of both Lean and Six Sigma. A lot of the work Henry Ford did. Here's a little quote he says that the little things that are hard to see, the awkward little methods of doing things that have grown up that nobody notices. And since manufacturing, or in fact transactional processes, are solely a matter of detail, these little things develop when added together into very big things. So we tend to lose track of what our process looks like. There's often the official documentation. We may have a routing and a manufacturing MRP system. We may have some documentation that explains what the process is. But a lot of times there's a big discrepancy between what we think it is and what it actually is. So when we talk about process mapping, I will iterate to the trainees, and what's about, guys, it's a graphical representation. That's really all a process map is. It's just a graphical representation. It's funny, I still wear a watch. Most people don't wear watches, but even friends of mine who have Apple watches, they don't display their time digitally. They display it, it's digital, but they display it with hands because we interpret things analog, right? We interpret pictures better than we do text, for example, even though text contains more information in some respects. But a process map is just a graphical representation of the process. But it's the actual process, not the way it was designed to be, not the way we wish it was, not the way management thinks it is, or anybody else, or even our systems, but the way it actually runs. And oftentimes there's a big discrepancy between the two. As you know, having had some experience with process improvement at any level, you start mapping out a process, and usually it's way more detailed and a lot more information than we thought, a lot more steps than we originally expected. The second thing about process mapping, it should be put together by the team, not the manager in their office, not the QC rep by themselves, not the engineer sitting, in the ivory tower, but by the team. And that team should include people who do that process on a regular basis. Dr. Lynn, a professor I had back in college, who actually was a little abrasive and I didn't like him very much, he reminded us, and he taught us this. He says, never forget, no matter your level of education or level of knowledge, nobody knows the process better than the person who has to do it every day. It stuck with me, and this stuck with me since last century, if you can imagine, right? But it really stuck with me, the idea that nobody knows it better than the person that does the job every day. So make sure you have them on your team as you begin your effort with process mapping. Now, the purpose of this webinar is to begin to think through the different types of process maps we have available. The process maps you see in the light blue, the SIPOC, the basic process map, even a deployment or a Swimlane flowchart, many of us are somewhat familiar with. And as you move left to right, that familiarity may change, right? As you get into the darker blue or the royal blue, we start getting into process maps that aren't as well known. And so I just have a quick question. I'd be interested to see in the chat. Which of these three, the main ones, have you done? Which one's your favorite? SIPOC, basic process map, deployment flowchart? The other thing is in this graphic, I'm really trying to represent that we'll often talk about process mapping. You should start with a SIPOC diagram. And in fact, if you follow the DMAIC methodology, if you're familiar with that, we'll often suggest that people do a SIPOC at the very first team meeting. It's a great team leveling tool. It's a great way to get everybody on board with what the main steps in the process are. Even introducing the idea of what's a supplier and what's a customer, and what's an input and what's an output. But it's a high level process map, and we intentionally keep it to no more than 8 steps. And I always encourage, process improvement members to try to keep it to 5 steps, right? What are they saying, Elizabeth, about favorite or mostly used?
So you've got SIPOC, but you've got a lot of deployment swim lanes coming up. Swimlane, flowchart, Swimlane and basic. Deployment swim lane process map is my favorite because it shows complexity and handoffs.
Yes.
And that's David. And Shane says mapping with root cause, brainstorming, and color-coded lanes.
There it is. Yeah. So people have got experience with a lot of these tools. Okay. One of the things we kind of like to joke about, and you may have heard this. This is actually a Elizabeth Swan joke. It's not a Jim. There's nothing new under the sun, as it's been said before. I have nothing original, right? But they call the SIPOC the Jerry Garcia map. I don't know if you ever heard that. Jerry Garcia, leader of the Grateful Dead, referring to SIPOC, said, stay as high as you can as long as you can. And the idea is try to keep it high level before you dive deep. One of the reasons is, and this is just a quick anecdote, I was at a manufacturing plant down in Florida. So I'm an engineer by training, as you probably read. But I was at a manufacturing plant that actually made paint mixers like you find in the Home Depot or the Lowe's, where you go take a swab and they'll make your paint for you. They manufactured those. And I was down and I was coaching a black belt on a project they had, and another black belt from a previous training session was in, and he asked if I would just look at his project and give him a couple suggestions. I said, I'm happy to. He takes me into their war room, which is a big, 20 by 40 room with a conference table and all. And he had this process map. It was on regular, 30-inch scroll paper off a plotter, and it was about 20 feet long. I mean, it filled almost the whole wall, right? And it was, and the process map steps are like this. And it was, I bet there was 500 steps on that process. I'm like, wow. He mapped the entire process from beginning to end with all the different type products they manufacture. And I said, well, wow, where is your project? And he goes over to this little area about that big, says, my project lives here. And I'm like, why did you do this whole process? Well, I was doing it for my project. And it's one thing to do that for your entire facility for one reason, but he actually did it for his project, which was an extraordinary consumption of time for very little gain, because he still had to go detail process map that. So we should have done a really high level SIPOC and narrowed down. So we like SIPOCs from that perspective, but you'll note I've kind of laid these out, and this is only a suggestion, right? Just laid them out in terms of 3 levels: high level, mid level, and low level. Some of these tools kind of straddle, right, one or the other. Some of them are definitely low level. Some are high level, like a SIPOC. So let's talk through each one just in some detail. I'll go through the first 3 kind of quick before I get to the other ones, right? We're going to talk mainly about a SIPOC process and a deployment flowchart just to begin with, right? And so we asked already, which one do you use the most? And it seemed like there's a lot of use of a deployment flowchart, a favorite tool. And we'll talk about that and some variations on it. SIPOC diagram, there's 50 different ways to do it. Interestingly enough, I did some training with GE back in the 20 teens, and they actually called it a COPUS diagram instead of a SIPOC. And, being slow-witted, I'm like, what is a COPUS diagram? I've never heard of that. And they're like, oh, it's just SIPOC backwards. I said, why? I said, well, because it's obvious. You almost always in a SIPOC, you start with a customer first and work your way backwards, and then sometimes fill in the process map at the last step. But we're familiar with SIPOCs. I won't exhaust that. I will offer this, though. I like to do SIPOCs on the very first team meeting for 2 reasons. For 3 reasons. Third, I'll do the first one first, is it introduces the idea of what is a supplier and what is a customer. We always think of supplier as people outside of our organization naturally, and people outside of our organization for customers as well. But in fact, we have more internal suppliers and customers most often than we do external suppliers and customers. So we introduce that idea that what is a supplier? It's not necessarily someone outside of the organization. We have internal suppliers and internal customers. Typically, your worst suppliers are internal and your worst customers are internal, oddly enough. Secondly, it's kind of a team leveling tool to make sure everybody on the team knows the main steps in the process. Now, this is kind of funny. If you go to a typical manufacturing plant where they're assembling ink pens, for example, or Sharpie markers, just with a little common sense, you can kind of follow through the process and see the main steps. Here's where they're, making the plastic cap, and here's where the felt is, and here's where they're putting the felt into the barrel, and here's how they're printing on the outside. You can just kind of see those steps you walk through. You start looking at some of our transactional processes, the back office, accounting, and HR, and even some chemical processes. There's nothing to see. It's just paper here and paper there and email. It's very common for people in those processes to only know their one step. I only know the programming part. I don't know how planning works. I don't know what happens to it after I program it. I know it goes to the shop, but I don't know. So it's a great way to get everybody on the team on the same page. The third reason I like SIPOCs is on the first team meeting, we all go to team meetings where we're not really sure why we're there. We're not really sure what the purpose of the team is. We're not even sure what we accomplished. We walk out of team meetings like, well, that was an interesting consumption of my time. But if you put a team together and the very first thing they do after you introduce the charter is you go through and build a SIPOC, then people can leave it and say, what'd you guys do? I don't know. We built some cyborg diagram, but did you know there's actually 6 steps to that process? I thought it was just 2. So people walk away with having learned something, and they did something in the team meeting, and it's moving you down that forming, storming, norming, performing, graduated scale of finally getting a team up to the point where they're functioning together. So I like a SIPOC diagram from that perspective. When we talk about basic process mapping, and this is just an example I threw up, this is with a client that I'm working with fairly recently, and they are managing raw material coming in. They have to sort it, restore it, a lot of stuff they're doing, a lot of movement. And you can see if we were to go do a VA NVA analysis, there's a lot of steps in here that don't make sense. And that's kind of what we're working through. But basic process map, by the time we get done with this, and you see end here, there's like 3 or 4 pages before this. And for simplicity's sake, in the COVID world, we are now doing these in PowerPoint. It's just easy to see them instead of trying to do like Visio, where you're trying to scroll constantly. It's hard to find things. Just been doing it in PowerPoint. Seems to be working quite well. But it shows us the main steps in the process: rework loops and inspections and delays and storage. There's a lot more, symbols. I won't go into the detail. You guys know basic process mapping. A deployment flow charting. This is an actual example out of a refinery. Use that word again. Refinery that I worked in. And they had big issues with their tanks. You've probably driven past large oil storage areas or natural gas storage areas, and they'll have those big cylindrical tanks out in a field, and they'll have 20 or 30 or 50 of them. And those cylindrical tanks are basically steel, and they have they'll fill it up with oil or whatever, gasoline or diesel or whatever the product is that's inside of them. Well, periodically, those things begin to get rust holes in them because water gets inside, and they'll have to take them apart and service them. In this refinery, we did some initial work on it. They were always, when I first got there and did some work, they were complaining a lot about how long it took to get a tanker or a tank redone. They'd have to open it, clean it, do it. If you sat down and did the actual process, it was about 20 days worth of work, actual solid work. And you could do it in 20 days if you had enough resources to do it. They were taking over 400 days to get their tanks done. They valued those tanks at something around $160,000 a month because they had the opportunity to buy product at less than market prices and bring it in, but they could only bring it in if they had a place to put it. If the tanks were all out of service, and so we went back and mapped it. And you know what we found out? It was because of the handoffs from operations to inspection, from inspection to engineering, and engineering to maintenance. As silly as it sounds, they would have to wait until the tank was released, and they would not start writing their shutdown recommendations until the tank had been released to planning. It would take them 2, 3, 4 months just to write the recommendations, none of which required access inside the tank. They just didn't start it yet. The other thing we found out, so there's this writing up work orders was a roadblock. If you were to do it on a Gantt chart, it was part of the critical path. They couldn't start the maintenance until that was done. We discovered that. We discovered there was some loss of information here and loss of, a deployment flow chart is a good way to think about that is like a relay race, right? And so you have 4 people running around a track in a relay. Relay races are somewhat about the speed of the runner, but more about the speed of the transfer of the baton, right? Every time you transfer the baton, it's a chance for dropping the baton, losing the race, stumbling, and so forth. And so the quicker you can hand it off, the better off. Well, that's what a deployment flow chart kind of illustrates. Every time you have one of these handoffs from one department to another, and the bigger the organization, the worse the departmental silo structure can be, right? You have a chance for loss of time, loss of information, handoff bobbles, etc. So it demonstrated that to us. We put some very simple fixes in and got the tank turnaround time down to about 120 days. There was still a lot of work that could be done, but they were so celebratory over just that gain. As you can imagine, we cut it by almost 3/4, just with some pretty basic stuff. For example, start writing the shutdown recommendations 3 months before you decide to take it out of service, which seems obvious, but there you go. There's another deployment flow chart. This is actually out of the same location, and we were looking at sign-offs for capital expense and request, or capital and expense request. And you have one delegated authority who has the authority to approve certain levels of spend, 250,000, 250 to $1 million, and so forth. If it was over $1 million, the refinery management had to sign off. At over $5 million, the refinery GM had to sign off on it. They still had 9 people had to sign off on it. And you're like, why does it take us, 2 months to get a capital expense request approved? It's because it wasn't because it took. If you hand carried it, it would take about 15 minutes because very few people actually looked at it. It's like, well, it looks like operations approved it. Okay, I approve it, right? Because it's really the DOA that had to approve it. When we demonstrated this and we showed why it was taking 60 days, it was we proposed one person sign off because that's really the whole purpose of the sign off is to get the approval from the person who has the DOA, the delegation of authority, or the authority to sign off on that money. And yet still some people wouldn't let go. But we made a pretty big improvement. So that's just another way to do a deployment flow chart. They talk about as you begin to learn tools, you see ways to move them around, to change them, to integrate different ideas into a tool to make it more meaningful for the particular task you're trying to accomplish. So as we move into these other types of process mapping, some of them are really just modifications of other process maps with additional things thrown in. Some of them are totally different, things you've never seen. There's a couple here that I've worked with belts and kind of developed, and I'm going to share those with you as well. All right. So value stream map, you've probably seen value stream maps, and they track two main things: product flow, usually from left to right, and information flow. Now, this is an example, it's cleaned up a bit, but this is an example of an emergency room. And we looked at their, care path and so forth. In this particular case, the average patient time in the ER was about 3.6 hours. How much time they were spending, not so much to wait to get to be seen, but the total time they would spend in the ER. And you see it's coming in from different sources, helicopter or ambulance, ambulatory, and you have people that walk in. There's triage, there's registration, there's blah, blah, blah. We threw a couple of things in here interesting. We threw stars in because in this particular ER, it was a relatively small location. The same doctor that did the assessment is the same doctor that did the evaluation, was the same doctor that would do the intermediate care, like putting in a stitch or setting a broken arm or whatever the case. And so as a result, you're sharing a resource, and that caused issues, as you can imagine. But we're probably familiar with value stream maps, and you've seen these. We have taken this, though, and we've created some other ideas around it, and I'll show you. This is a value stream map for a company that does some domestic manufacture of a product. They ship it overseas, as evidenced by the boats, right? They ship it overseas to get some contract manufacturing done. They ship it back in, and then they finally ship it off to the customer at the end. We actually took this value stream map and we tracked the cycle times and we tracked all that. This one doesn't show all the completion stuff, but we also tracked the dollar add, because one of the things they were concerned about was where are the costs being accumulated on this particular process. And we were able to go back and we started looking at where the dollars added at each step in the process. So it was just a kind of a twist on a typical value stream map, which value stream maps are really looking at end-to-end cycle time. It's also at GE Aviation. We had a story that circulated internally called the wing to wing cycle time. That was the time from the plane engine came off the wing, came out, went to service, got rebuilt, and eventually got back in inventory and eventually got back on the wing. So they would talk about the wing to wing cycle time. And oddly enough, we also talk about the ring to ring cycle time. From the time the phone rings with a customer order to the time the cash register rings with our remittance, right? So the ring, so you hear it, end-to-end cycle time, wing to wing in the GE example, ring to ring in the, in the process flow in terms of customer order to ship. But that's usually what a value stream map is looking at, is the total cycle time. But we were actually changing it a bit to look at the total dollar add, interesting enough. Now, there are a couple of things I could share with you. If you're really interested, you could contact Elizabeth. I could share this with you. But this is a value stream map that we created for manufacturing or transactional processes. And it goes through a very detailed calculation. It's in Excel. We excluded the information flow. We mapped that elsewhere. But on this one, we map in the cycle times, the setup times, the units per setup typically. And that could be by product, by location, by step. It could be by work order. It depends. Total cycle time. And then we go through a calculation of OEE, overall equipment effectiveness. Long story short, at the end, it does a calculation for you. Up top, you put in your takt time information, and then it creates a line balance analysis, right? And then we can find out which steps in the process are exceeding our takt time. And it gives you a targeted area of what to go approach. Taking that, then we can then go and address, okay, that's our current state. I'm going to back up. That's the current state. Here's the future state. And then we use the concept of Kaizen Bursts, right? So we had the team brainstorm and we set up some tactical things or some strategic things we wanted to do. We then numbered those Kaizen bursts, and there is now a detailed numbering sequence that matches each one of these Kaizen bursts. Some of these numbers don't show up properly because of when you scale it down for the presentation. But all of these Kaizen bursts refer to, they're the ones that hover above up here in the information, the description of how the calculations work. Those are ones that universally affect the process. Ones that specifically affect steps in the process, the Kaizen bursts are obviously assigned to those steps. And then you go at the bottom and there's a list of that. Now, just as another aside, when we do Kaizen Bursts, we broke them into 3 categories. They were either, we call them JDIs, just do it. Some people call them Nikes, right? Because that used to be their, their motto. We call them just do it, things we can just go out and do, doesn't require a lot of effort. Some were Kaizens, that is, we were going to do a 1 to 5 day event where we'd go address these issues, things like rearranging where inventory is stored, for example. And a third one was an out and out project where you're going to have to go work a, 2 week to 4 month project to actually go address a specific issue, for example. But we would take those individual Kaizens, assign them to the individual steps or hover above. All this is pre-work that had to be done. And then we would say, are they a JDI, or are they a Kaizen, or are they a project that has to be worked, right? So that's just another take on a value stream map. All I'm doing is introducing some different ideas on how we did it. This Excel spreadsheet works wonderfully. It's so much easier. You even put your loading here. What happens if we add another person? Everything recalculates for you and shows you, does it alleviate, right, the bottleneck? What happens if we improve the quality, we improve the performance, we improve the availability? And it actually goes through and all self-calculates and shows what happens to you. At the end, you get a sense of what your VA to NVA ratio is, if you're familiar with value add, non-value add. So you can see here before, it was awful at 9%. Our proposals should take it to up to 25% and reduce the cycle time substantially, right? So that's just another take on a value stream map. Elizabeth, getting any interesting comments other than I talk too fast?
I am. And you got that Southern accent going, so it kind of just like we just go with you. You're getting people very excited about this template, and they want to know if that's something else that you might share.
I would be happy to. Yeah, it's proprietary. It's something I developed. As long as I don't get any comments about spelling errors or minor, but I'm happy to share it. Yeah, it's been really powerful for me as far as using it with clients, and it's just. And the other, just another comment on this. I have done it myself, and I have been with other people who have done value stream maps, and people come in cold and have nothing prepared ahead of time. So as a result, you wind up having a team of people sit in a room for 3 or 4 days just to come up with this level of information. What we've been able to do is by sitting with a couple of managers ahead of time, getting all the initial information, and in some cases you can get the routing and the bill of material if you're familiar with those documents that come out of MRP. But get those documents. I can pre-build a value stream map, and usually it's about 85% complete. So when I show up for the very first team meeting, right, with the core people who know the process that you're trying to get that real information out of, we've already got a valid template with a lot of the information pre-filled in. We even know what the staffing is, more or less. So literally, I have gone in with clients when I've done this, and by the end of the first day, we're already brainstorming what the future state looks like, as opposed to by the end of the third day, you finally have your current state done, right? So this has really facilitated that, and I'd be happy to share that. Yeah. There's also, just so you know, it's self-explanatory, but every one of these little blocks here has an explanation of what the calculation is up top, right, and how that works. It even shows you, in some cases, what the math is. The tag time is somewhat self-explanatory. The best thing is to get it and just play with it, and it's pretty self-explanatory when you play with it. Spaghetti charts. Oh, we love spaghetti charts. I mean, they're called spaghetti charts because when you label everything out on the map, it looks like a plate of spaghetti, right? This was a shop that rebuilt pumps, and they would bring a pump into a central location, and the pump would be given to one of these operators. There are like 9 operators there, and they'd be given the pump. Well, then they had to walk to all these areas to get their work done. You'll notice these numbers. Those are steps in the pump rebuild process. There was a lot of travel time in this process, and we were able to make some significant improvements in the cycle time just to reduce the walking. Here's a funny thing, funny in an odd way. By the way, I was born and raised in Georgia, and I live currently in Alabama. Most everybody down here takes things nice and slow. And somehow, I don't know, growing up in Atlanta, my mama was from Missouri, I talk really fast, so I apologize. The good thing is I can get a lot of training in. That's how we do black belt in 4 hours, right, instead of the normal 3 weeks. I'm kidding. But we went back and we mapped all this out. We were able to make significant improvements just by rearranging the workflow. The other thing you find out, though, in spaghetti charts like this is when you have these long distances that have to be traveled like this, people who work these jobs wait until they have 2 or 3 or 5 or 10 before they go make that journey. It's like you don't run out and buy, potato chips when you run out. You wait until it's time to go buy groceries. Well, the same thing here. People will wait and they'll just accumulate their things that they want to walk over to some part of the shop to do their work. This was an interesting example. You could do it. This is like a CAD layout of what the shop looked like. This is a Google Earth view of a spaghetti chart. As you can figure out, this is actually a refinery down in the southeast. And it was just interesting. These green pentagrams, pentangles, 5-sided stars, whatever they're called. Anyway, those are log in and log out areas where they would have to scan into an area and scan out of an area that's protected. They did a X-ray they would take pipe and weld it together, and then they had to X-ray the pipe weld to make sure it was good. They did it in the laydown yard. So they would do the manufacturing here, move that pipe all the way out to the laydown yard, and they would call the non-destructive testing group to come out and do their test. Well, the non-destructive test group was located way over here, right? They would call them up. They would then get in their truck, drive all the way, right? Get to here, scan out, drive over here, scan in, drive all the way out to the wharf, sign in, then they drive all the way back out, scan out, drive over here, scan in, and then finally get to the place where they were doing the work. It took them 37 minutes just to get to where the work was done, right? There's only about 30 minutes worth of work. They literally were spending almost twice as much time driving and scanning and signing in as they were doing the actual work itself. And then when we illustrated that with the spaghetti chart, we were trying to go from a traditional NDT test, which is X-ray. With X-ray uses a poison pill, if you will. It's a small piece of, plutonium or something that emits, rays that are dangerous, just like going to the dentist and getting an X-ray in your teeth. So they had to have a protected area. That's why they didn't do it inside the refinery. We actually were able to go to a different type of testing. It was an ultrasound testing that was just as accurate. It just wasn't new. This convinced management to make the change. Right? Spaghetti chart in this case was a very powerful tool in that particular project. There is another tool we have called a value-added flow analysis. Now, I throw this in as a process map. It's not really a process map per se, because it's certainly not graphical. What it is really is a serial list of every step in a process required to do a particular activity. A couple of things that happen here. Every step is numbered, obviously. Is this batching or individual? Some things are done per each. You get one, you do it per each. But some things are done in a batch. You wait till you get 5 or 10 before you do it. When you transport from something on the first floor to something on the second floor, you usually wait till you get a few before you walk up the stairs or go to the elevator. You don't want to go up there every time you get one. You spend more time walking than you do working, right? So people naturally batch, and that's what you kind of see here. So we got individual batching. Who's doing the work? What are the exact tasks? And this is broken down to a lower level. This isn't it's certainly not a SciPoc level, and probably not a mid-level process map. This is a more of a lower level. Hours per cycle, minutes per cycle, occurrence per cycle, extended time. At the end, you put in what your value add, non-value add. And just as a reminder, for a step to be value added, it has to meet 3 criteria. It has to physically change the thing, right? Change its form, fit, or function. It has to be so important the customer will be willing to pay for it. That is important to the customer. And third, it has to be done right the first time. Rework is never value added. We always start with the assumption that nothing in the process is value added, right? And so then we just assume everything's non-value added. And then you have to force it to be value added. That's a complete top-down look, because we typically look at our process and say everything we do is value added or we wouldn't be doing it. Well, that's not true. If you've ever done these, you realize that. Anyway, this is a great way to understand where the time is going and how much time we're actually spending on things that don't matter. Very powerful tool for mapping that. It's not really a process map, but I threw it in anyway because it's a favorite of mine, especially in transactional processes where no one person really knows everything that's going on, right? And you start mapping that whole thing out and look at those, it's really appalling. Look at, if all of that time, that's how much is value added. And this isn't the whole process, it's 100 and some odd steps long. Anyway, this is another deployment flow chart. This one has some, a dozen or so different departments or individuals it has to go to. And these are the steps it goes to. This was a process that I worked on with an organization that had a employee reward program. and employees would get bonuses every month based on their performance on generating product, on their machine uptime, and on their safety record. So at the end of the month, it's like you should, for the previous month, you should then get your reward for a month well done, really close to the time that you finished it. This process was so bad, 21 days after the change of the month, on average, 21 days before the people got their bonus. So it's like trying to teach a dog a trick and giving it a treat tomorrow for the trick it did today. There's no reinforcement, right? We mapped out the steps and we showed, this is what you notice now is a secondary swim lane vertically to show which day on the count of day 1, day 2, day 3. You'll see this, nothing happened on day 3 and 4. It's not because of the weekend, it's just because they didn't do anything on day 3 and 4. And you'll notice 5, 6, 7, 8, and you notice how the time was stretched, and you begin to realize, why are they waiting to take, and then because they would give certain departments 3 to 5 days to report in their information, when it should have been known at the time the month was closed. So it's just a variation on a deployment flow chart. It's a deployment flow chart with time designations, as you can see. All right. Here's a process map with brainstorming tools. Now, we do process maps. This is actually a repair process where a part was shipped in, like a cell phone or whatever, you ship it in to get it repaired. They were actually doing the repair south of the border. So they would bring it in the repair center, redistribute it, send it over the border. They'd get it back, redistribute it, send it then back to the customer. This can be used. So we often do brainstorming affinity analysis or fishbone, but what we could do is look at a process map and say, well, what could happen at this step in the process to cause that problem? See, the way you do it, you put the problem down in the bottom right-hand corner, and then you just go through each step. Just a few of these have been shown, right, just for reference. But we would go to each step and say, what could happen here to cause that problem? What could happen here to cause that problem? So it's a little bit different look than, say, a fishbone or an affinity or just an open-ended brainstorming. So process mapping with brainstorming. And this is a take on some people, they've got X, Y process maps where they'll put all the X's and the Y's at each step in the process. I was never a fan of those. They're very cumbersome and you're recording a lot of information that may not relate to your problem. So this is kind of a modification where we're only looking at what is the problem you're trying to solve. I'm very pragmatic when it comes to that, right? Sometimes it doesn't make sense to do swim lanes because it makes the process map so big, right, and so cumbersome. You can't map it all on a single sheet of paper. So one variation is to, instead of using swim lanes, color code the steps, right, and then have a color code key that coordinates with who's doing what in the process. As long as you got color printers and you got color monitors, that makes sense. If everything's black and white, obviously it won't work. But it's really just a swim lane, but instead of using actual swim lanes, we use color-coded steps to indicate who's doing what. You still get the sense of handoffs you can see there. And you got handoffs all the way through the process where you can see where it's changing color. Here it's being distributed to different groups, right? Another very powerful tool, and this is more of in my experience, more of a manufacturing tool where we look at the flow of product from the time it's introduced to an area to the time it's exhausted out of an area. Very handy to begin to understand where all the pipes go, for example, what they're feeding into. So this is just showing product that's going through basic chillers and knockout drums and different valves and understanding exactly what that valve does. What's it, how does that pump work? Which direction is it pumping and so forth, right? This is a really interesting example. Again, a physical process map. We had people, they were having trouble wrapping their head around this. We would buy, or the refinery would buy oil, and they had a supplier storage they'd buy it from. The supplier would take it out of their storage container, put it in a tanker, ship it to a different storage location, intermediate, who then would put it in another tanker and basically ship it to the refinery. You'll notice these S1, S2, S3. These are all points where samples were taken of the product moving from the supplier storage. So there's actually sampling before that when it comes out of the ground. They take it out of the ground and put it in the supplier storage. So we're ignoring the drilling and extraction part of that process. But they would move it all the way through the process. They measure salt in the oil, chlorides they call it. Chlorides is very destructive to a metal, right? And so we were worried that they would, we were trying to make sure that we were getting the right chloride content. As we started looking at it, we found things like here the chloride content would be 2 ppm, and then here it'd be 8 ppm, and then here it'd be 4 ppm, and here it'd be 6 ppm, and by the time we got it, it's back to 4 ppm. You're like, there's no way the chlorides go down. It's one of those things that it's like mixing salt in your water, right? You can put salt in your water, but if you put a little bit of salt in your water, unless you do something mechanical or electrical or chemical to get that salt out, it ain't coming out. And so you get salt in the oil, it ain't going to bounce around. It's only going to get worse as it goes through. So if it starts at 2 and it winds up at 4, but it got to 8, it's somewhere in here, something's wrong. And it was basically turned out to be a gauge R&R issue. But we kind of, you asked the team about it, and they're like, well, we sample it here, we sample it here. Nobody had a clear view of it. So we did this process flow just to kind of show this is really a gross in the simplistic way. But it's a very simplistic model, but it was really revelatory to see all the sampling points and why they're sampling and where they're sampling. And we wound up finding we had some significant gauge R&R issues. Most of the salt was coming off people's hands due to poor product handling, oddly enough, right? Or off the surface of the tanker, because salt water would get inside of the oil tanks. Here's just another variation of that where you've got 2 pieces of equipment. One is supposed to be held in reserve in case this one goes down. And it just shows how the different bottles and the first and second stage of a compressor all relate together, right? But again, it's very easy to trace what happens when you look at a process flow diagram like that. So it's similar to a process map in this example. I'm going to back up a couple of slides. Here, you actually have engineering symbols that indicate what those things do. Here, it's just the process map, but we've got the names to indicate what they are. A lot simpler for, us lay people to do, as opposed to the other one, you have to have specialized icons. Sometimes you have to deal with IT systems, right? And this is the same same refinery. I'm just pulling out a couple because I worked on there for a while. But we did some work in this one. They had several software systems, SAP and the PI system and Wharf Manager and Info Plus. And there's this paperless pumpers log. It's kind of funny. There's some obsolete system. But we thought, oh, well, they have SAP. They had all these ancillary systems. We mapped it out. And one of their issues, they had a demand to do some extra work, and they had only so many full-time equivalents, FTEs, employees. They didn't have time to do the work. We mapped this whole thing out, and the belt did it with a little bit of help in IT and just talking to the people who did the different steps in the process. And oddly enough, they found out these Kaizen bursts are 3 reports that were being generated that nobody looked at. And so in one case, it would take a resource a day and a half to generate this big, long, detailed report, only to find out nobody looked at it. And you wonder, how does that happen? But I've seen that over and over. I'm interested. Swanee, anybody have any comments yet? And does anybody have any comment where they found a report that was being generated that nobody looks at? And it takes a great deal of time.
That's a constant that you and I have both seen. Shane said, I have found those. I suspect as people start to, old leftover, quote unquote, fixes. That's Mary. David says, absolutely. And shameful. So it is a sore point. It's a thorn.
Yeah. Elizabeth and I have a colleague that we work with, and he was working in a transactional process. It was paperwork processing area. And he was sitting with one person, did some coaching, and he sent with another person. He says, isn't that report a pain in the neck? She goes, yeah. She says, wouldn't it be nice if you could stop it? And she's like, yeah. He says, well, if I found out that the person that you send that report to never used it, would you be willing to stop it? And she's like, yeah. He literally stood up, talked over the cubicle to the person who was receiving the report. She didn't know who was receiving it. She was just sending it up. And he says, I never look at it. He sat back down and said, quit making it. She said, okay. But it was that easy. Nobody knew, right? But yeah, that was really the outcome of this IT systems flow. Gantt charts. I'm not going to belabor this one, but a Gantt chart is really a tool we use to understand the number of steps have to be done, and they're sorted into, not sorted as in weird or odd, but sorted as in TED, not DID. But they're sorted into the flow, and we look at critical path. We look at interdependent versus non-dependent steps. We look at things that can be done in serial versus in parallel. And it tracks for us over time what tasks have to be done. This was actually a hiring process that we went through. Nobody had ever mapped it out. And as a result, it was taking them up to 9 months to go through the hiring process. And we were able to get it down in a ridiculously long 3 months. But that was a big win for them. They were very excited about it, right? So just some ideas. Now, I think there was a poll that was put out. I don't know. Elizabeth, talk to me about the poll. Have we put that out yet?
I'm going to put that out for you now. Let's see. Yeah. It's this one is, which of the following maps it's my typo, not yours, have you been exposed to? Pick all that apply. So I'm going to launch that and let folks chime in. Do you see?
Yeah, very interesting. Value-added flow analysis is kind of a rare tool. I would get that one. Deployment flow chart with time designate, that was a very specialty tool. I'd be surprised if many have used that. The other ones you would kind of expect. Yeah, you would get Gantt chart. I guess that one took the lead on the highest leg on the Pareto, right? Interesting enough, I'm always surprised at who knows what a Gantt chart is and who doesn't. I did some work in an organization that had a great deal of planning they used for some of their maintenance events. And they had a particular software they used that generated their whole planning thing. And so I went and I asked them about the Gantt chart they were using, because they actually had a Gantt chart they were creating. They looked at me like I had lobsters coming out of my ears. They'd never heard the term Gantt chart. It was just something they used in their software. It's like, oh, you mean I can't remember what it was, time designation flow chart or something. I can't remember what they had a name for it. It was odd. Look, it's a Gantt chart. So yeah, very common tool, very commonly used in project management, right? As we all know. So
one more question for you, Jim.
Yes, please.
Audrey asked if everyone is excited about reading a new report and says they want to see it weekly, but they stop reading it. Any ideas for keeping reports fresh or deciding when to stop sharing them?
Yeah. Let me ask the quick question back. Is the report distributed via paper, or is it a report distributed electronically?
I'm going to wait for her to respond. We've got Steve offering upvote, Audrey. People don't always know who could possibly be looking at the report, so it's hard to find out who might still find it useful. Or someone uses the report from every month, but only checks once a year, and reporting monthly keeps data problems fresh and flexible. Audrey says it's electronic. And Steve says, yeah, electronic mostly.
Okay, is it a follow-on question? This is just now we're getting to coaching mode, and I slipped into that rather easily.
Sorry.
No, it's cool. I would ask the question then, is this distributed to a specific known distribution list, or is it generally created and populated out? If it's populated out, I would figure out a way to track who's looking at it, right? Maybe you can get a system solution to do that. If you're distributing it via email or some known distribution list, it's very easy to go query those people. Are you looking at it? What are you looking at? I have found a lot of times reports will have, in many cases, a lot more information than the key bits somebody needs.
Right.
So I would ask those questions and even ask, can I just automate this report? Or can this be something that can be done automatically without having to do a lot of manual intervention?
Yeah, I think you're right about that. It's usually overproduced, too much information.
Yeah.
And they're chiming in on, let's see, Doug says, I found people say they want to read it for fear of being left out. Then they lose interest when they find out they don't really need it. So there's like
nobody else is reading it either. So I don't want to be left out on reading something that nobody's reading, right? It's like War and Peace. I got a copy, but
not reading it. Okay, those are great. Thank you, Jim.
Brilliant. Other questions before we go forward? Elizabeth had mentioned, I will share this with you real quick, and this will be distributed at the end. I did put together just a quick little discussion of each one of the type of process maps that we discussed here. It has the name of the process map, the general idea of what level it is, a description, a purpose, and even some interpretive outcomes. What would you do with it, right? What's the purpose of the tool? And that's one of the things I always drive process improvement, practitioners to think about. Before you go do a tool, think about what your outcome is going to look like and what are you going to do with the outcome, right? We tend to jump in and just do a tool because that's the one we've always done or that's what we're used to. But always think about, okay, let's pretend I have that tool completed now, that process map, that SIPOC diagram, that Pareto, whatever. Okay, let's say I've got that. Okay, what am I going to do with it as myself? So anyway, this kind of gives you some interpretive outcome on what you would do with that on the back end. And it goes through all the process maps we worked through today, even with pictures of the same one. And so that'll be distributed after we get done, if you would like. So I'll go back here. And Elizabeth, I don't know if you want to see if there's any questions in the chat.
No, I think there was a good dialogue there. Folks trying to help Audrey out in terms of, the idea of reports that are either overproduced or have too much information or people aren't reading them or some beautiful combination of the two. So that was a good conversation there. I'll leave that open. So chat or questions, anything else folks want to extract from Jim's rapidly moving brain. Really, a really big appreciation on the bonus chart there, Jim. That's nice. Nice for me too. Those are nice. I like the way you've sort of laid out the big view of a lot of maps. You're really inclusive in terms of the reality of how many maps we're using, and that's just kind of the hybrids we know about, but we know that we just keep changing and hybridizing these things.
There's so much more. You always think it's like, well, there's a SciPoc, there's a basic cross map, and did I mention the SciPoc? It's like there's so many more than that. Yeah, and that's the advantage of talking fast is that's actually a 2-hour presentation, but we're done in like 45 minutes.
So here's a question from William. How do you decide which approach and tool to use?
Wow. I really try to begin, as Stephen Covey said, I try to begin with the end in mind, right? What do I want to know? And I really try to teach processes as if they are a sentient being that will answer my questions, but only in the binary, yes or no. Now, they'll give me the information I want, but they won't answer the question. So I have to think, how do I structure my questions to the process, right? And be able to get the answer back graphically or mathematically or through some other mechanism. So I started thinking about if I want to look at something over time, is a value-added flow analysis the best way to do it? Would it make sense to do it with a deployment flow? So I kind of think of that perspective. How do I need to look at this problem? And it really is dependent on the problem. But I try to think through, what do I want to accomplish by asking that question? And then what tool is going to answer that question for me? That's the way I approach it.
I love the idea that you're asking it questions that can be answered in a binary way. That I had not thought of. All right, you've got one from Terry. What process do you use to define a future state? Do you focus on defining a future ideal state or some target condition?
Yeah, we almost inevitably, they talk about 3 levels of process value stream maps. There's the current state, the future state, and the ideal state. I don't really mess around with the ideal state too much because sometimes it's too much in the nether region that doesn't make sense. It's all like in the cloud, and it's well, if we had $7 million to spend on this new piece, it's like, who's going to have that? So we usually look at what can we accomplish in a block of time, usually between 6 and 12 months, right? And we say, okay, let's look at our process. What could it look like in 12 months with this sort of budget and this sort of time to work on it? And we'll start listing out things. And we'll even use things like pace diagrams. I don't know if you've seen pace diagrams, but you can take ideas and throw them up on the board, and then you prioritize them. It's just a prioritization matrix where you have your scales, ease to implement and the amount of payback or the amount of benefit you get out of it. And we actually invert the scale for ease to implement. So super easy at the top and difficult at the bottom. So we want everything in the upper right-hand corner where you get a lot of payback and it's easy to do. So we kind of look at our brainstorm ideas, and then when I'm doing a value stream map, we will specifically look. Can I back up, if I may, for a moment?
Yeah.
What we would do is look at this. We would first of all look at our line balance analysis and identify, okay, we've got a problem here with that particular step, and I got a problem with that particular step. And these are they're called space manufacturing. They're actually a soldering and welding process. But I recognize those are my constraints that allow me or prevent me from meeting my tack time. So we'd say, what would I have to do at that step to fix that problem? And you look at it, you realize, wow, you're running at 79% performance. If the standard's correct, we're running slow. Why are we running slow? Second, we're running at 82% quality. Why is that? Well, we found out we had a significant soldering problem on that one. So we said, okay, if I'm going to work this and I need to get this to a specific level of performance so I can meet my tack time, I got to fix that problem and that problem. It's actually the same problem. They would do they were manufacturing cables. They do half the cable, send it to X-ray, do half the cable. So we would do it like that. And we would go back, and then you'll notice here, a lot of these Kaizen bursts were brainstorms from the team. And we would ask the team, okay, what specifically would you like to see done? So I kind of balance, when I'm doing this with a group, I balance between what the team wants to see done with what we strategically have to do to hit the tack time or hit what the customer demand is. 2 reasons. 1, we get the payback for management, so they actually see the benefit of shipping the product. 2, you can use this as a mechanism to alleviate a lot of minor headaches for people who do the process every day. And it's kind of a win-win. It benefits both directions, right? If I can fix this quality issue, people don't have to do a bunch of reworks. They're happy about that. If I can fix some of these minor layout issues that may not really result in a lot of time savings, but make it just easier for people to think and do their job, you get a big win there too, right? So that's kind of the take we usually look at. what's our budget, what is our time frame for getting things done, and that's the way we generate what our future state's going to be.
Nice. That's great. Thank you for that walkthrough. We've only got a few minutes left. Let's do a quick walkthrough of what's to come, and then I'm going to come back to one more question. And Robinson, the video is going to be available. We're going to send links to everybody who registered. Okay, so just a quick thing. I'm going to poke a bunch of links into the text. Let's see. So you guys can have them. Upcoming next webinar. Brian, I don't think Brian speaks as fast as Jim, but he is also on the entertainment scale. He listed on the entertainment scale. How to solve complex problems in a virtual lean environment. This is fascinating. He's got folks from Port St. Lucie. His question is, have you ever tried to tackle a multi-million-dollar problem with a four-year backlog in a pandemic involving 5 departments with a need for intense collaboration while socially distancing? He's got a great example for you where they completely used remote techniques to help Port St. Lucie. So that's going to be a fascinating webinar on May 20. So you've got a link there to sign up. Go ahead, Jim, next. This one is new. I've run this a couple of times now. In the moment, using improv as a people skill. I did improv, as Jim may have mentioned. I was on stage for about 5 years, way back in my career, kind of catapulted my career, made me figure out if I could be on stage with no script, what couldn't I do? So improv is problem solving on stage. And these workshops are to help people basically respond in the moment, increase their flexibility, increase their ability to work with others, and embrace the concept of yes and, to always build with other people. So 2.5-hour workshop, links in there. I highly encourage you to come. We've got public and private versions of this thing. It's been awesome. Off the hook successful. Okay, next up. Podcast episode, new one out with UC San Diego Health and how they invented the lean vaccine superstations. That is fascinating. Don't miss that. Links there for you. And I think the last one there, that's just info. So let me come back. We've got 2 minutes. Jim, I'm going to ask you one question from Dave. He said, I believe that you can have too many metrics. How would you approach key performance indicators, KPIs? How important is it to track KPIs that the customer really cares about?
Yeah, there's a hierarchical level in KPIs, right? And oftentimes KPIs can be subsets of other KPIs. So when we take the dashboard approach, this is an old term that we use to refer to trying to build important metrics that you track. We use a mechanism or a thought process called a drill down, right? And so like on a dash of a car, you think there's only 2 or 3 or 4 gauges. There's not 19 gauges. If it is, it's a jet aircraft. It's no longer a car. And they found even in jet aircraft, they had to simplify the number of gauges because you get a task saturation and the pilot can't fly the plane because you're too many looking at all your 5,000 gauges, right? So what they do is they try to focus on 2 or 3 or 4 critical gauges. If you need more information, you click that gauge and it blows down to 6 sub-metrics. And if you need more information on that sub-metric, you drill down and there may be 4 or 5 underneath that. So one of the recommendations is figure out a way to make your KPIs hierarchical. So you've got the top 2 or 3 that you focus on, and you can drill down to more detail below as needed.
Yeah.
Little boy is taken on board of a pirate ship and he sees the pirate captain. He's just amazed. And the pirate captain, the hat, the patch, the whole thing. Little boy's just so excited because he's going to be the cabin steward for this great pirate captain. He says, gee, Captain, how'd you get your wooden leg? He says, French cannonball took me a leg off Canton knee. Had to get me pegged. Little boy's like, wow. He says, gee, Captain, how'd you get your hooks? He says, a British lieutenant cleaved me arm off with his cutlass. Had to get me hook. Little boy's like, wow. He says, gee, Captain, how'd you get your eye patch? He goes, is the first day with me hook.
Oh, you're bringing back memories, Jim. Thank you so much.
Good times.
And, you got bonus jokes along with the bonus value stream map templates and mapping guides. Thank you so much, Jim. It's such a pleasure. We're not in person, but almost as good. Getting a lot of thanks from the folks here. I will resend the improv link with everything in the email follow-up along with Jim's bonus templates and guides. So generous of you. Thanks, everybody. Bye, everybody. Take care.
Cheers. Thank you.